which process has a higher slope on a TS diagram, whether it is a isochoric or isobaric process. And of course, this is a information which is a standard result, I would say, in many of the thermodynamic discussions. Of course, how would you decide that the last stage of a typical civil gas turbine engine requires a nickel-based alloy? That is, last stage of compressor disc needs to be made out of a nickel-based alloy. Now let's look at two thermodynamic situations, one from GATE 2020 and the second one from a typical engineering research interview. Now, the first question that is asked is which process has a higher slope on a TS diagram, whether it is isochoric or isobaric process. Of course, if you derive an expression for entropy for the same temperature ratio, you can appreciate that the entropy change is in fact higher for isobaric process when compared to isochoric process. Of course, if you consider the slope, it is higher for the isochoric process and lower for isobaric process, which again goes to justify that entropy change is higher in case of a constant pressure process or isobaric process compared to the constant volume or isochoric process. Now, you can also see the figure. If you consider same two temperatures to begin with as well as to end with, you can see that the entropy change for same two temperatures is actually higher for isobaric process. And if you measure the slope, and of course this is a information which is a standard result, I would say, in many of the thermodynamic discussions, of course in our course also. The slope is given by temperature divided by CV, and for similarly for constant pressure process, the slope is given by temperature by Cp. And also we know that Cv is less than Cp, and therefore what one can conclude easily is the ratio of slopes is this, and also the slope for constant volume process is higher. So that was a very simple question based on standard information. Now let's move on to the research situation. Now, one of the research questions that tests your real-time understanding of data for a typical gas turbine engine. Now, based on basic thermodynamic arguments, how would you decide that the last stage of a typical civil gas turbine engine requires a nickel-based alloy? That is, last stage of compressor disc needs to be made out of a nickel-based alloy. Now, of course, temperature has several effects on the components. It degrades the mechanical properties, brings down the yield strength, brings down the UTS, brings down the Young's modulus. It brings down the natural frequency. It increases the buckling susceptibility. It also increases the susceptibility for corrosion. It can also affect the fatigue life of a component. So therefore, temperature becomes a very important parameter. Now here, one of the information that you require is the engine pressure ratio. Of course, the compression happens over 3 stages. But here, for ideal calculation, we assume that it happens over 1 stage. And if you looked at the typical civil gas turbine engines, the engine pressure ratios are around 45 to 50. Let's assume an engine pressure ratio of 50. And if you use the typical equation for adiabatic compression, not accounting for inefficiencies of the compression, you would see that approximately the last stage of the compressor sees a temperature of 600 to 700 degrees centigrade if the engine pressure ratio is between 45 to 50. And this temperature definitely calls for the use of a nickel-based alloy. So therefore, by basic thermodynamic arguments and also a real-time understanding of certain data of the product, you can in fact tackle such questions. So one of the organic takeaways of this discussion is it is not just being familiar with the structure of a particular product. It is also important to be familiar with some of the real-time data of the product. It could be the maximum temperature seen by the product. It could be the power that the product could generate. It could be the RPM. In this case, we needed the engine pressure ratio data. So therefore, it is very, very important, apart from the fundamental understanding of the thermodynamics, the product details also have to be appreciated. So let's continue.